One more task that I would like us to do together is one where we have three forces. So let's imagine again a box. On this box we'll have three forces acting, so we'll have three vectors. Let's say the first one acts perfectly eastward and has a magnitude of 20 newtons. Let's say another force acts 45 degrees at a 45 degrees and has a magnitude of 10 newtons. And now let's add in a third force. Let's say we have a force acting in this direction and has a magnitude of 30 newtons. This would be an angle of, let's say, 135 degrees to the positive x-axis. Okay, when we have 3, 4, 5, 6 vectors, the method of solving them or adding them is always the same. We break them down into components one by one. First of all, does this one have a component? It only has one component. It only has the x component. So let's draw it on our axis. 20 newtons in the positive x direction. Okay, here's another one. Magnitude of 10 newtons, 45 degrees, and this is something we do on and on, which is finding the x and the y component. How can we find the x or y component? This is easy because we have an isosceles triangle. Again, if you know your trigonometry, you will know that x and y in this case will have the same exact magnitude. If you don't trust me, you can try to calculate it yourself. All right, here's our, let's, for example, say we will use sine of 45 degrees to find opposite side, which is going to be our y component. Okay, so it's going to be our y component over our hypotenuse, which is going to be 10 newtons. Therefore, to find y, and y in this case is equal to x, we're going to have to multiply sinus of 45 degrees by 10. Plug that into your calculators. What you should find is that these are both equal to 7.07 newtons. Okay, how do we represent it on our coordinate axis? Okay, so other than the 20 Newton force, we have one more force acting in this direction, correct? The x component is acting in the east direction and has a magnitude of 0.7 newtons. It will also have a y component acting towards the positive y coordinates with also a magnitude of 0.07 newtons. Okay, and we have our third component, third vector. And with vectors like these, it's much easier if we break down this this angle into a angle that would just bring us to the positive y-axis, because this way we have a right triangle and we can use simple trigonometric expressions to find these two sides. And if we do that, we will find that this angle is going to be 45 degrees, right? Because here we're going to have 45 degrees, and here we're going to have 90 degrees, which will add up to 135 degrees. Okay, the magnitude of our hypotenuse, 30 newtons. The opposite side, in this case, is going to be our x component, and the adjacent side is going to be our y component. Again, we have an isosceles triangle, which makes things much simpler. x is going to be equal to y, which is going to be equal to cosine of 45 times our hypotenuse, which is going to be equal to 30. Again, put the numbers in your calculators. What you should get is 21.21 Newton. 21.21 Newton. Okay. Now, in which direction do these components act? The y component is going to act upwards. So now we have two y components acting upwards. This one has a magnitude of 21.21. And we'll have one acting westwards. So we have a new direction now. No component acted westwards so far. And this one is going to have a magnitude of 21.21 newtons. Okay. When two components are acting on the same side, we simply add them up. When they act on the opposite sides, we subtract them. You already know this. In this direction, in the west direction, we have 21.21 newtons. In the eastward direction, we have 27.07 newtons, because we added 20 and 7.07. And in the north direction, or the positive y-axis direction, we will have 21.21 plus 7.07, which should give us 28.28 newtons. Okay, now these two components act in the opposite directions. What do we do when the components act in opposite directions? We subtract them. So what we do is we subtract 21.21 from 27.07, and what we should get is 586. So here's our x component, 586 acting eastward, and our y component remains the same because we only have one y component, 28.28 newtons. When we have this, again, we do something we did in every previous task. We use the Pythagoras theorem to find our resultant force. Now, if you use the Pythagoras theorem, what you should get as the result is the magnitude of the resultant force is 28.88 newtons. And you should find this by 5.86 squared plus 28.28 squared, and then you will root it, and you will get the resultant force, which should be 28.88 newtons. Okay, are we done? No, we're not done yet, because we need to find the magnitude. We need to find our angle alpha. How can we find the angle alpha? We know all three sides. We always use the tangents, so let's use tangents. Tangents of our angle alpha is going to be opposite over adjacent. The opposite side is going to be 28.28 divided by the adjacent side, which is 5.86. Again, plug that into your calculator, and what you will receive is 78.56 degrees. No, sorry, 58.53 degrees. With respect to the positive x-axis.